Hi, thanks for attending. We're going to be talking about full stack FHIR development today using FHIR resources on the client, the server, database, and throughout your entire application stack. My name is Abigail Watson. I'm a clinical informaticist educated at the University of Chicago. 15 years of experience ranging from MUMPS administration to Cerner administration, now FHIR development. Before I start, my background, I have 2 degrees. My degrees are in history of science and medicine and biomedical informatics. And in many ways, I consider myself to be a clinician, not a technologist. Trying to focus on clinical work, I'm always kind of looking for tools that simplify the technology and let me spend more time on the clinical. The entire motivation behind full stack FHIR development is so that you can focus on the clinical. So I run a business called Symptomatic, where we've been putting together sort of what we believe is a new class of applications. This is our continuity of care document viewer and parser. We have, this is the dashboard for our product. We have a longitudinal timeline, which we can pull in FHIR resources from different places. We also are heavily invested in geomapping technologies for epidemiology and transit routing. So these are kind of different kinds of apps that we wanted to see in the healthcare ecosystem. And we kind of were looking around for other types of ways of building applications. So we started with JavaScript. And this was many years ago. I started doing a lot of consulting and helping companies make websites and apps that the name of the game was they needed to be HIPAA, FDA, and EHR ready. And that's kind of what everybody asked. And after doing after doing it a number of times, we settled on a web application framework called Meteor, Meteor.js. Meteor is developed by the Meteor Development Group. They're based out in San Francisco and was originally founded by a team of MIT engineers. And they provide an API for JavaScript. They initially build themselves as the .NET framework for JavaScript, and they provide a number of, one might say, supportive API methods, sessions, accounts, passwords, templates, timers, trackers, and they kind of curate it, just like .NET is a application a framework that you can build applications. They do the same thing with JavaScript and Node. So what was really interesting when they started was they gave a list of principles, kind of what they stood for, and Meteor allows you to develop in one language. And that's, from a clinical perspective, that is huge. Being able to say that we're going to work in JavaScript and that's the language that we do is kind of a game changer in some ways. Meteor uses data on the wire, meaning the server sends data, not HTML. It's very ecosystem driven. It's very, it is completely open source, and what they try to do is they try to stay in the center of the ecosystem rather than maybe trying to lead in different directions. They're constantly trying to be in the center of where JavaScript is. So in that regard, there's stewardship and they're curating JavaScript. And then they also provide full stack reactivity. Well, the core thing that they do is they provide like a build pipeline. They take a bunch of packages and their build tool kind of bundles all these packages up and prepares it to be deployed out in the world. So that's work as a clinician that I don't have to do, and I'm all for that. So it's been tested, and other people who are better at those things can concentrate on the build pipeline, and I can be concentrating on the clinical stuff. The one language. So what's really interesting is Google's Chrome environment has been ported to the server and the database. So MongoDB uses V8, the V8 interpreter as their interpreter. We also have the V8 interpreter in Node.js, and we have the V8 interpreter in Chrome. So we have the same JavaScript interpreter on database, server, and client, which is awesome. So when we talk about full stack reactivity, they've done a whole lot of wiring and plumbing. Things that you would normally have to do in Node, kind of stitching together libraries, they took them all together and just baked them until they're actually so baked together that it's difficult to kind of pull them apart. But we have the analytic, we have the cron jobs, we have the analytics aggregation pipeline, we have webhooks, we have the publication, subscription, then you have client-side reactivity, components, and then compiling to your devices. So they took all these kind of things, put them all together. In practice, this is the browser's console, and you can see JavaScript, which is, you're all familiar with this. This is showing an observation that we fetched, and we have a observations find fetch, which if any of you use Mongo, you will notice that we're using the Mongo API on the client. And that's a library called Mini Mongo, where they said we want to have the same APIs on both the server and the client. This is going to be a theme that we're going to repeat again and again. This is our database. This is kind of a production database, and we've set up all of our collections to be based on the FHIR resources. And so this is on the server. That's on the database. This is the server logs, and you can see our publications. We have a patient publication getting started up, risk assessments, and so forth. And so we're using FHIR on the server, on the client, on the database here. I was really excited when I first found out about Meteor, and so I was like, we need to make this ready for hospitals and clinical environments. So for the past few years, I've been curating what's called the clinical Meteor project. It's not, the easiest way to think about this is like a Linux distro. They have something called a release track, and the release tracks are a way of publishing subsets of the Meteor framework. And so I should back up, is I got started by doing a Meteor cookbook. I was collecting little snippets of code here and there, and it turned out to be popular. We got 1,600 stars on it, and it became kind of popular within the Meteor community, and we eventually kind of started moving that into a software development kit. And when I say software development kit, it's really kind of a, I don't know, like a dumping ground or a junkyard of JavaScript projects that we see, and we're like, oh, that's interesting, that's interesting. I'm a little bit of a magpie in that regard, where I'm kind of like, oh, I want to save this. And so we put this together, it became popular, and over time, we started forking packages and saying, we want to take these packages and we want to get them ready for clinical work. We want to try to whatever extent we can, get them under quality control, add FHIR to them, just kind of try to get them all into one place. So the clinical Meteor track is the clinical version of Meteor. We set up a Circle quality control system, so we run validation tests across the framework. We would like to get the publish releases a little more regular than we do, but we do quarterly. We do quarterly verifications through the entire QA process. For an open source project, it's what we can manage, but quarterly is better than none, and it's been keeping things on track. So full stack FHIR architecture. So everybody knows what FHIR is at this point. We have an API of all these different data types. Well, we wanted to get FHIR throughout our technology stack. And the tech stack roughly looks like Material UI, React. We have D3 up in the, for the visualization layer. We have Apollo with, for GraphQL. We have Meteor doing our pub/sub infrastructure. And then we support a number of databases, NoSQL, graph databases, and IPFS is a swarming technology. And we've been putting FHIR kind of through all the different parts of it. Cumulatively, this represents nearly 300,000 GitHub stars, and we've been really trying to get the best technologies that we can and stay in the center of where things are. We've been very happy with all of this. The build pipeline consists of taking many of the node packages, which some of you might be familiar with NPM, and Meteor runs its own package manager called Atmosphere, which is a little bit more abstracted, a little bit more not the building blocks of the JavaScript technology, but a little bit more what are the workflow blocks. And so we compile the node to the Atmosphere. We pull both node and Atmosphere into the clinical release track. We put all those together, and then we have a project called Meteor on FHIR, which is our it's a reference app. We kind of use all these different pieces together and put them into what is functionally a interface engine, and we use it as a router, an interface engine, and the base block for building apps. In some senses, it's like WordPress, where it's envisioned as a cross between Mirth and WordPress, if you're familiar with those applications. FHIR Microservices. So this is our technology stack, or this is the microservice that we just talked about. Then we have cron jobs and aggregation pipeline. We have webhooks, pub/sub, and then client-side Mongo, and the data stores for your components. We've been putting FHIR through all of that, and it becomes sort of a data layer, and you can see the FHIR resource go through the entire stack, and it's really great. We support replication sets, so because we're using Mongo in the back end, it scales up, and you can install it on sharded data, and it supports up to petabyte big data models, and so this is kind of the big data architecture approach. So yeah, H07 resources. So for each one of these microservices, the package strategy for these is kind of what one can have philosophical arguments about how you structure your packages. And we've taken the approach that each package for FHIR resource should be able to cover all the components in this microservice. So in the clinical Meteor track, if you search for H07 resource, you'll find that we've stood up 62 repositories that match an H07 resource. The canonical example of why you want to do this would be the location resource, because Mongo can support two-sphere indexes that optimize for geospatial queries, and you want to custom code your microservice to do geolocation things. Medications might have integrated RxNorm components. Observations might have integrated SNOMED. So for each one of these resources, our concept was that there's enough one-off edge cases that you want to have a package for them, and you want to put all your edge cases in there. So what does one of these look like? H07 resource, or the patient resource, just like we're going normative with R4, the H07 resource patient package is our, I would say it's our gold standard for these. It's gotten the most attention, and it's the most developed. So I should back up. And so we have client lib, which is shared on both client and server tests. And so we're organizing the package by folders with the different parts of the technology stack. And so you can see it, each package is like a mini application, if you will. So on the client, we have React components and the user interface. And you'll see our API, the patients find one. That's accessing the local cursor named patients, and that lexicon, that syntax is going to be available throughout the package. And so we see it fetching a specific patient. We see it, we're spot checking a field within the object tree to when rendering. On the server, we've been supporting subscriptions for nearly 4 years now, and we have our Meteor.publish, and we name the subscription patients, and we return patients.find, and that's on the server. So once you learn the API, you always know, how to do your queries, and you don't have to be what's the syntax for this SQL on Node or whatever. Once you learn it, you become productive. Schema models. Isomorphic, both on the client and server. So this code runs on both client and server, and we have a custom schema library called Simple Schema. We're migrating towards JSON schema with the rest of the ecosystem because JSON schema is the center, and if the community is moving towards it, we are too. Webhooks. We've had webhooks for 2 or 3 years now. And again, isomorphic. This runs on both. We have webhooks on the server. We have webhooks on the client. So when the data layer sends a FHIR resource to the client, the cursor will have a hook saying, okay, on insert or on update, I just received this. I'm supposed to run this whatever. We use this for relaying, we use it for auditing, we use it for pipelining so that you can kick off additional functionality. REST endpoints, so it's on the server, and again, we have the JSON routes that defines our REST endpoints, and it calls our patients.find1. It runs isomorphically. When you use a stack, the isomorphicity starts. You're like, wait a second, can I run a REST endpoint on the client? And the V8 interpreter, there's the code will compile, and you're like, well, that's okay. We have had prototypes where people have tried running web servers on the client, which enables peer-to-peer topologies. So if you want to build a peer-to-peer network, you can. Validation tests, again. We're using a FHIR resource right in our validation tests. And we're like, it's just JavaScript, so pull it in, use it as a data type. And then obviously we try to get this under QA. So we've been putting this through the touchstone tests and trying to get QA on it also. So webhooks and data pipelining. This is not your traditional SQL approach. We have a very NoSQL-centric architecture. So instead of SQL queries, we have to do data pipelining. And what does that look like? So we're going to take that diagram for the microservice and we're going to rotate it 90 degrees. So it's vertical now. And we have our cron job, our aggregation, our webhooks, publication, subscription, client-side, reactivity, components, devices. And now we're going to do a couple of them. okay, we're going to stand multiple microservices up next to each other, and we're going to do hooks, one to the next to the next. Data pipelining, and then you start building out a larger for a workflow. This was a questionnaire workflow where we took the users, collaboration, studies, form builders, questionnaires, and so we're kind of creating an application data model, which is not inherently unsimilar to a UML diagram. Okay, so this is roughly the same as a UML. And then the ones in yellow are our FHIR collections. So we have custom microservices, we have the FHIR microservices. You can connect to the FHIR microservices through your traditional REST endpoints that you all are familiar with. But then the webhooks are kind of, they do automated shuffling between the pipelines. And then you want your inbound interface and your outbound interface. And through all these things, you can create a data pipeline. We developed this at UC Santa Cruz. We sometimes call this the redwood methodology because thinking of the redwood trees and shuffling them one to the next to the next. And then putting it all together, you can build larger application workflows. So this is you know, a workflow that we did. Putting all of this together, we can do advanced network topologies, such as app-to-app interoperability. So we have a tendency in the Meteor system, Meteor ecosystem, to stand up multiple servers and have them talking to each other. We'll just kind of pull two servers up and have them pinging each other. The base build installs via Docker. It's themable. There's a plugin architecture. It's similar to Mirth. How many people have used Mirth? People? Yeah. So we envisioned it in the same way as we're going to take this and we want to build a base build that we can kind of install wherever we need it to. And what that does is that kind of creates that peer-to-peer network as we talked about. And so we support mesh network technologies. We can use this as a FHIR relay and as a FHIR interface engine. We see it a lot like the Plex media server. We've had some great success with IPFS, which is a bit swarm or a BitTorrent type technology, and it swarms between them. And blockchain applications are super simple with this technology. The router interface engine, we go back, and so now this is probably making a little bit more sense. We have the drivers to connect to the different databases and different data sources. They pull it into the server. The server, because it's isomorphic with the client and the other nodes, they can just kind of replicate between each other because the V8 interpreter is the same on each of them. And this allows distributed databases, and that's where we get blockchain applications. So we've been looking at how to stand up blockchains. We've currently got prototypes with BigChain, Interplanetary File System, that's the IPFS, Hyperledger, and Ethereum. The ones that we've had the most success with were BigChain and IPFS. We caution against Ethereum for various reasons, but it was one of those things where it came to us, and we didn't seek it out, and it was like, oh, well, yeah, we have all these libraries, and it works out of the box, and so it's been pretty painless for us. Meteor on FHIR, how to get started with all this. So that's the base build that we talk about, and if you go, getting started is really about saying, I'm going to go read the documentation on Meteor.js. So you can think about Meteor.js as a extension to the FHIR API that actually deals with the technology stack and not the interoperability. So we see this as an addition to FHIR. It's isomorphic in the same way. So, so between those two things, start with the Meteor API docs. And then the Meteor on FHIR project is where we recommend kind of on-ramping. And it's, we keep this under QA, and so it looks like it's last updated 3 months ago, but that was our last release. And we're quickly approaching version 1.0. There's going to be a desktop app that we published that has a bundled continuity of care document viewer in it. And then if you get into the branches, you'll find all the latest releases and, or the latest work. And then the installation, you know, you clone it, you clone it to your local application. You'll need to install Meteor, and you need to install Node. It'll walk you through all these things. You go into meteor.app. You can pull in plugins. The plugin architecture allows you to write, like WordPress, custom plugins where you can keep your intellectual property, your business cases, your tests, QA logic, and so forth. And then you add it, then you Meteor npm install it, run it, and up it goes. Yeah. So it's all documented. Go enjoy, and I ran through it kind of quickly. Thank you. This was a crash course in our experience with taking FHIR and putting it throughout the stack. And if there are any questions, I'd be more than happy to take questions.
I'm not that familiar with JavaScript to begin with, but I know there's something called like AngularJS.
Yeah.
Does this compete with that, or augment that?
Yeah.
Or does it fit with other frameworks? AngularJS and support for multiple rendering libraries. So Meteor supports AngularJS and TypeScript and a number of, it really is agnostic and kind of supports a lot of different libraries. React is the default, and the React is where we have been investing in creating a user interface. So the most support is in React, but people do compile it, and the appropriate thing here is to look at the tech stack slide, and you have to replace 2 of those libraries, and you can keep the rest of the stack, replace it with Angular if you wish. It's more work. Questions?
Where all in the stack do you validate the FHIR model?
What's that?
Where all in the stack do you validate the FHIR model?
Yeah. So the schema is kept in the H07 package library, and so it's. I don't know if it. I'm trying to think which slide would best explain that. So it's isomorphic, and what that means is that the validation library, the schema validation, gets loaded up on both server and client, and it's actually validating in multiple places. But we define it in one place in the H07 resource package in the lib folder. Yes. We also, with the newer JSON schema approach, we will also be supporting validation on the database, and yeah.
How much security implementation?
Yeah, great question. How much security is there? So it's multiple levels. We support data encrypted at rest via Mongo. That requires an enterprise license, so be forewarned. We support per transaction crypto libraries that can encrypt before you save to the database. We support client-side cores and access control. We support security on the publication subscription. There's security baked in at
basically each point in the stack. So if you need security here, 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 like there's a checklist of different items where the security checks are added. So big throughout.
At what layer do you do that per resource? Or
Repeat that.
you sharding, I'm saying the word right. MongoDB. At what layer? How do you do the sharding?
The charting? Like the visualizations? No, oh, sharding. Yeah, so that's gonna, the sharding runs on the question was where do you do the MongoDB sharding? And that's within your Mongo data cluster, and you set up the Mongo cluster to be sharded, and that would require a custom index defined in your package. So you would create a package, you would define it in the server folder to run the shard index key, and then it populates out. Yeah. Well, the great news about, so the question was Mongo and support for ACID transactions. So as of the latest version of Mongo, they do support ACID transactions. It was a major release, and so it is now official. We did have arguments for number of years about the relative, and we could have conversations about the CAP theorem and consistency, accessibility, and partitioning. We believed that even without ACID compliance, that convergence to consistency was an acceptable model for many applications, and so we were willing to take that risk to begin with, but then Mongo said, yeah, we'll get you ACID transactions if you need. So.
What if we have a non-Mongo feature? What if we wanted to use SQL? How
Yeah. The question is SQL support, and what if we have an existing SQL database? So we have an integrated GraphQL server that is part of the technology stack. So this center part right here, that's our GraphQL server, which was recently announced into the standard. We actually did the proof of concept when people were asking, can we do GraphQL with FHIR? We had a community, open source. We had had a community member donate a version of GraphQL that used some FHIR resources and endpoints, and we were like, yeah, we did a validation, we did a proof of concept, it works, and then that got introduced into the Zulip conversations. You can pull up the old conversations, and that started off a whole subsequent chain, and so yeah, we support SQL both through the GraphQL server, but also through native NPM libraries. We've had a lot of success with SQLize and so forth. So you just add the library. There's less reactivity. The user interface doesn't necessarily automatically update with the SQL. You have to sometimes do the refresh, maybe polling. Any other questions? Demo? Well, I want to thank you and let you all get some coffee. And this was a crash course, and that's how we do. If you want that kind of programming experience, it is available. And we found that with the isomorphic approach, the single language, that our productivity increased nearly 5-fold compared to like a LAMP stack and so forth. And so projects that were taking us a month, we started being able to roll out in a week. Projects that were taking 6 months, we were doing in 2 months. And that time savings you can spend in two different ways, or a couple different ways. You can either take on bigger tasks, or you can reduce the number of people required to do the task. And so you can use the cost savings benefits in a couple of different ways. We like to use the time savings to add QA process into our workflow, and to focus time on the clinical problems rather than the technology problems. Thank you.